Now we can start getting into some more information about just how the eye sees. So we know that light has to hit the retina, and that is how the eye then forms an image. One of the important things is that the light must be focused when it hits the retina. And that is the job of your lens. The lens is what focuses the light on your retina. And the lens changes shape in order to do this. So we have two scenarios here. We have this one is where you're looking far away. The person's looking at those mountains in the distance. And we have this one where the person is looking near. He's looking at his watch to see the time. So we're going to look at what the lens does in each case. And the eye can be kind of confusing because it's a little counterintuitive of what's happening here. Okay, so we'll start with far vision. For far vision, you want the lens to be flat. So the lens is like a ball, and it's like a squishy ball. Think about a squishy ball. If you just leave it alone, it's a round shape. But you can put pressure on it, you can squish it and make it flat. That's what the lens is like. So in order to make it flat, you have to do something to it. It wants to be round, you have to pull it flat. So the lens has to be flat to focus on far objects. So you have to actively pull it flat. So remember those suspensory ligaments? They are what pull the lens. And remember, this is a cross-section picture, but they actually go all the way around. And here is the ciliary muscle. It is what controls the suspensory ligaments. So in order to pull the lens flat, the suspensory ligaments pull it. This is the part that gets a little confusing though. In order for the ligaments to pull the lens, the ciliary muscle relaxes. When it's relaxed, you see this arrow? When it's in its relaxed position, it moves posteriorly in the eye. So a relaxed ciliary muscle moves posteriorly, it moves back. So this means it moves further away from the lens. Well, since it's moving further away, then it pulls the suspensory ligaments, which in turn pull the lens. And when you pull the lens, it flattens. And now you're focused for distant objects. So you can see here, the image of the mountains is right there. Notice also that it's upside down. Your eyes see the world upside down, and your brain flips it back right side up. But all of the signals coming out of your eyes are upside down. Now we can look at near. So for near vision, you want the lens to be round. So it's going to be fat and thick and round. In order for the lens to be round, notice these ligaments. See how they're slack? Remember, the lens is a ball, and a ball wants to be round. So if you imagine you have like a squishy ball, if you take your hands off of it and just leave it alone, it's going to be round. It's only flat when you're squishing it. So the ligaments go slack, and the lens automatically pops back to being round. Notice here the arrows. The ciliary muscles move forward, closer to the lens, and that's what allows the ligaments to slack. And in order for this to happen, muscles have to contract. So when you're looking at something close, to focus on a near object, you have to contract your ciliary muscles. When they contract, they move anteriorly in the eye. So they get closer to the lens. Well, since they're close to the lens, those ligaments go slack. So there is no pressure being applied to the lens. And in this lack of pressure, the lens automatically springs back to being round. And now you are focused on something near. So that's how you work to focus the light. Now you can have problems. A lot of people have glasses because they have problems with focusing the light on the retina. Now this is not a comprehensive of everything that can possibly go wrong with your eyes. So I might go through this and you might think, well, but my eyes do this or my eyes do that. We don't have time to cover every possible problem with the eyes. So we're just going to cover a few basics in the problems that can happen. So we're going to start off with the one all the way over here on the left is emmetropia. This is just normal. So this is our one to compare to. And this, everything's working. The light focuses just fine for both near and far vision. Our next one here is hyperopia. This is also known as farsighted. In this case, things that are far away you can see fine, but things that are close are blurry. So if you're farsighted, you can focus on far objects. But close is blurry. So compare this eyeball with the normal eyeball. Notice this eyeball is kind of short and squished. Look at the length of the normal one. So in the case of farsightedness, the eyeball is too short. And having this eyeball too short means that when you're looking at something near, the focal point of the light is back here behind the retina, where it should be if the eye were a normal size. So the correction for this is a convex lens. Another common problem is myopia. This is also called nearsighted. If you're nearsighted, you can focus on near objects. But far is blurry. So compare this eyeball, look at its size here, compared to the normal one again. This time the eyeball is too long. And so when you look at a distant object, the focal point is where it would be if the eye were the right shape. But since the eye is too long, the light focuses before it hits the retina. This is corrected with a concave lens. Another thing that tends to happen is presbyopia. This occurs with age. So think about the lens and that squishy ball again. When you flatten the ball, then you let go, it automatically springs back to being round. Now say you spend 40 or 50 years doing this. Eventually the ball is just going to start to stay flat. It's going to lose that elasticity to spring back to round. Another thing to think about is like your socks or the waistband in your shorts. You can stretch elastic and it will spring back, but only for so long. Eventually your shorts start to lose their elasticity and your socks start to slouch. So with age, at about 40 or 50 years old, the lens loses its elasticity. So you pull it flat to look at something distant, but then it does not spring back to being round. This means that near objects get harder and harder to focus on. You can tell when somebody's starting to have presbyopia because they complain that their arms aren't long enough. Think about maybe your parents or your grandparents sitting in a restaurant and holding the menu out far away, or reading a book or a magazine and having to hold it out far away. That's a sign that presbyopia is occurring because you can't focus on anything that's close. So in order to read, you have to hold it out far. Or they get a text message and they hold their phone out as far as they can trying to read it. So with age, the lens loses its ability to spring back to round and you can't focus on near objects anymore. Visual acuity is the measure of how well you can see and focus things. So there's a lot of misunderstanding here. For example, what does 20/20 vision mean? A lot of people think that 20/20 means perfect, but it doesn't. 20/20 vision means you are average. For humans, perfect vision is 28. So let's look at these numbers. The 20s are distances from the chart. So you have this Snellen chart. The 20 is how many feet you are from the chart. So the first number always represents you. This means you are 20 feet from the chart. The second number represents the average person. So this means the average person is 20 feet from the chart. If we look at perfect vision, the 20/8, this means that you are 20 feet from the chart. So let's pretend you have perfect vision. The 8 means that the average person is 8 feet from the chart. So what this means is that you can see from 20 feet, which is farther away, what the average person has to scooch up to 8 feet to see. So if we have a chart here, here's the chart. You can stand here at 20 feet away, whereas the average person would have to stand here at 8 feet away. And you would be able to read the same line. So you and the average person would be reading the same line, but you could read it from 20 feet away, whereas they would have to be 8 feet to see it. So then poor vision, let's say you were 20/30. This is below average. If you were 20/30, here's the chart. Here's you at 20 feet. And you can read a line. An average person, however, could step 10 feet further away and read that same line. They could be 30 feet away to read what you have to scooch up or stay at 20 feet to read. So that's how visual acuity works. You are always the first number, and that first number stays. You are always at 20 feet. So the first number is always going to be 20 feet. The second number is the average person. This is the number that changes. It's where the average person would stand to read the same thing that you see at 20 feet. So you can see that on the chart here. So here's the one that's average, 20/20. You and the average person can both read this line from 20 feet away. Here's the 20/30. You are still 20 feet away, but the average person can step 10 feet further back and still read that line. Here's 20/15. You would be 20 feet away and read this, but you have better vision. The average person has to move up by 5 feet in order to read that line. So now when you hear somebody talk about 20/20 vision, you'll know that that is not perfect. 20/20 is average.